here we're going to look at trying to write an equation, maybe the most simple equation we can to model this real life scenario. It says you purchase a phone card for $15, long distance calls cost 16 cents per minute. After one call, your remaining balance is $10.04. How many minutes did your call last? Maybe you're checking the bill to make sure it's correct. And when in the world, it's been a while since anyone used a phone card, right? Maybe if you're making an international phone call or something. Okay, but the best part about story problems, you can usually take this whole little mini paragraph and boil down just the information you need to really very little. So if I read through this, what's important? Well, that I started with $15 on my card and I ended with $10.04. So I use that piece of information and that piece of information. And what's the only other thing that's really pertinent in here is that these calls cost 16 cents per minute. So we can erase this whole paragraph. We have all the information we need, and just we want to know how long did this call last. So given this information, can you maybe logic this out without an equation? Yes. But what you would do is actually the exact same steps you'd end up doing once you have an equation. So maybe if the thing we don't know here is we want to know how many minutes did this phone call last. So we write down what's the thing we're looking for. The thing we don't know very often wants to become our variable. So we don't know how many minutes the phone call was. We could use X, but let's be more creative. We'll use M to be our variable for the number of minutes. So think, how did these calls work? Well, you started out with $15 and then you lose balance for every minute you use. Well, how much balance do you use? You lose 16 cents a minute. So if you would talk for 1 minute, 16 cents. 2 minutes, 32 cents. Notice we're multiplying the number of minutes. It's 16 cents for every 1 minute. So I can see, oh, I need to multiply 16 and M. Now be careful, if we have 15, this is in dollars. So when I go to write down 16.16, otherwise we're charging 16 cents or $16 a minute. So we're just to have a starting balance. We lose 16 cents for every minute we talk. And at the end, we were left with $10.04. So now it looks like we have a workable equation. What we started with minus what we used should equal what we ended up with. And so now we can solve this. So if I want to get M by itself on one side of the equation, maybe I'll subtract 15 from both sides. So negative 0.16 M on the left equals 1004 minus 15, so $4.96. And negative, because 15 is the bigger one. And whenever you get to things like decimals, I'd probably, if I can, check on your calculator, even if you think you can do them in your head. It's nice to not have to go back because of a little mistake. So do something and double check on the side. So now last, negative 0.16 is multiplied by M, so to get rid of it, we could divide both sides by negative 0.16. And this is good too, because we knew we can't have a negative number of minutes. But look, our negatives are going to cancel anyways. And so we'll end up with 31. Then probably a very good idea to check, and we want to write down, we don't want to just circle M as 31 when we're done. This meant something to a real life problem. So currently we're saying that our answer is that our phone call lasted 31 minutes. And if we want to double check, we could do 31 minutes times our 16 cents a minute to figure out how much money they charged us for this phone call, which gives me $4.96. And if I started with $15 and I take away $4.96, I'm left with 1004. So it looks like it checked out to what was actually supposed to happen.